In this video, we will use HTML, CSS, TypeScript, and React to build a simple encrypted notes application. If you're struggling to start building your own app, you can follow this tutorial, then improve the app with better design and more features, and add it to your portfolio. In the process, you'll also learn the basics of using local storage, basic encryption, rich text editors, debouncing, and most importantly, a process for building your apps. So let's get started. We will be using Vite to set up the project. You can copy the npm create command for React TypeScript. Now run that command in your terminal, navigate to the project folder, and run npm install. Now you should have your project ready, so open it in VSCode. I recommend setting up ESLint when working with JavaScript. It helps to catch small errors in your code, such as typos in your variable names. To install it, run this command. It will add the ESLint package and the config from create React app, which includes some sensible default rules for React apps. We will extend it in our ESLint config. To do that, create a new file called .eslint.rc and paste the extends line. Finally, install the ESLint extension in VS Code. It should now start catching errors. I also recommend using Prettier so you don't have to worry about formatting your code. Simply install the Prettier extension, toggle format on save, and change default formatter to Prettier in your VS Code settings. Vite also comes with CSS Modules support, which we'll use, so I recommend installing the VS Code extension to help with styles auto-completion. Now remove all of the files added for Vite example project because we'll be starting from scratch. Also remove the style import in main.tsx and remove everything from the app.tsx file. As a starting point for our styles, we'll use normalized CSS. It will ensure our styles are consistent across all browsers. So let's install it and simply add the import in main.tsx. Now let's create a new CSS module file to hold the styles for the app component and import it in your app.tsx file. Let's start building the app by creating a basic layout of the sidebar and the editor area with a toolbar inside of it. We'll add the text editor itself in a moment, but first let's add the layout style. Start by creating a class for page container. Its height will span 100% of the viewport height. Add overflow hidden and change its display to flex with flex direction of row. Next, add the sidebar class. Its height will also be 100% viewport height, but we'll fix the width at 15 rem. Change the display to flex and set flex direction to column. Finally, add a gray border on the right and enable scrolling with overflow auto. Now let's create the class for editor container and also set its height to 100% viewport height. Turn it into flexbox with direction column and add flex grow 1 to fill all of the available area by default. Add the class for toolbar, then change it into flexbox and align items to the center. Finally, add a gray border at the bottom. Now open your terminal and run npm run dev to start Vite development server. Go to the given URL and you should see your app running with our basic layout. To build our notes editor, we'll use a library called Tiptap. Grab the command to install it from their docs and run it in your terminal. Then import it in app component and render it below the toolbar using the code from their example. You should now have a working text editor, but it starts at a single line and has an ugly outline. Let's change that. Add editor props to the editor config and set the attributes to include a class named text editor. Then add the text editor class to the app CSS file, set outline to none, change it to flexbox with direction column, and set flex grow to 1. Now the editor looks a bit better, but the editor area doesn't scroll. So give a new class to the editor content component. Declare the class in the app CSS file and add overflow auto to enable scrolling. Then add display flex with direction column and set flex grow 1 to fit the whole editor area. It will also look a little bit nicer with some paddings on the sides. The editor looks better now and it's scrollable. We can now start building the toolbar. The editor docs have a great example that we can use. Let's start by adding the button to bold the text. Give it a class and the onClick handler. Like in the example, we'll chain the two commands, focus and toggle bold. Declare the class in the style sheet. Give the button a padding and a small border radius. Then set a white background color and a dark gray text color. Remove the border completely and change the cursor to pointer. Finally, on hover, set a very light gray background color. You should now have a bold button, but there's no indication that it's toggled. Call is active on editor and toggle between toolbar button and toolbar button active classes. Then declare toolbar active class in app CSS file and set composes to toolbar button, which is simply a CSS modules way of extending another class. Finally, give it a lightish gray color. Now it's easier to tell that the bold text is toggled. So let's also add the button to toggle italic text. Simply copy the bold button code and change the toggle bold command to toggle italic. You shouldn't be fussing over usable components when you're just starting out. I'll remove this justify content rule I've set by mistake and add a small gap between toolbar buttons. Now you should have two controls, one for bold and one for italic. To generate globally unique IDs, I used the UID package. but also feel free to use the native UID function instead. I will install UID package for production builds and its types for development. Now, add a button in the sidebar for creating new nodes. Give it a class and onClick handler. We will need a place to store the nodes, so add some local state using the useState hook. Import it from React. It is helpful to declare the node type. The node will have an ID and the title that are both string, content with content type from Tiptap, and the updated add date. We should also inform the TypeScript that our useState hook will contain an object record of string IDs and nodes. Import v4 from UID package, and inside our create new node handler, create a constant for the new node. Assign the ID of the new node to the result of calling the UID function. It will generate a globally unique string of characters. Assign some static text to title, then use a template literal with some HTML as initial content. Finally, set new date as updated at. Now we need to update the node's object and component state, so spread the nodes already in state and add the new node indexed by ID. We also need to give the button some style, so declare the sidebar button class in the app CSS and add some margin and padding. Let's also set the border color to white. Give it a small border radius, light gray box shadow, a border of the same color, and bold text with dark gray color. We should also set the cursor to pointer. For hover styles, we'll give it a slightly darker border. It looks good now, but it would look even better with some other font. For that, it's helpful to have a global, non-module CSS style sheet. So let's create it now. To get a new font, I recommend using Google Fonts. It has hundreds to choose from. I'll pick Noda Sans and add all of the variants I'll need. I'll also copy the import line and paste it into my global CSS file. Add a style for body element and paste the font family from Google Fonts. I will also set box sizing to border box on all elements in order to avoid weird quirks with their sizes. Finally, import global CSS file in your main TSX file. Now your text should use the new font. Let's render the list of nodes next. Use object.values on nodes record to get the list of nodes. Sort it in descending order by the nodes updated at times. Now create a container for the nodes list inside of the sidebar and give it a class. Using the map function on the nodes list, render the nodes titles inside of the list container. Each item should have a key, a role button, and a tab index 0. Give it a sidebar item class as well. Next, go into the app module CSS file and create the sidebar list class. Give it display flex, flex direction column, make it scrollable by setting overflow auto, add a small gap between the items, and give it some padding at the top and bottom. Now also declare the class for the sidebar item, give it some padding, some margin on the left and right, a cursor pointer, and a small border radius. For hover style, give light gray background color. Now if you create nodes, you should see them added in the sidebar. To toggle between nodes, we will keep the ID of the active node and state. So create it using useState and set it to null by default. It's also helpful to let the TypeScript know that it can be string or null. Now create a handle changeActiveNode function. It will accept the node ID. Set the active node ID in the state with that ID. Finally, assign it to onClick handler of the sidebar item. Before we proceed, we should extract types and node editor into their own files. So let's create the types.ts file first. Move the node type there and export it. Clean up the imports, and create the node editor.tsx file. Create and export a node editor function. Declare the props type and make it accept a node of our node type. It should also accept onChange handler. We will pass it content of JSON content type from Tiptap. Add the component props to editor component function, then copy the editor container JSX code from app.tsx to our new editor component and return it. Finally, copy the use editor code and the toolbar button click handlers. Now create the node editor CSS module file and move all of the toolbar and node editor classes into that file. Add all of the missing imports, and instead of the static hello world text, pass the node content from props. Tiptap has onUpdate callback that's executed when typing, so we can use it to call our onChange function. And since we need JSON content, we'll call getJSON on the editor before passing the result to onChange function. Finally, we want the internal Tiptap Editor state to reset when we change between nodes. Fortunately, it can be handled automatically if you pass the node ID to the dependency list of the useEditor hook. This basically associates the editor with the node. Then in the app component, we can derive the active node by taking it from the nodes list using the active node ID. We can use it to check if there is a node selected, and if not, render some message for the user. Otherwise, we will render the new node editor component. As a node prop, pass the active node, and for the onChange handler, pass a function called handleChangeNodeContent with active node ID and content as arguments. We will now create it. So define the function at the top of your app component and declare node ID and content as parameters. Here we'll set nodes in state, keeping all nodes unchanged except for the one we're editing. For the selected node, we'll copy unchanged properties, which is only going to be ID at the moment, and set updated at to the new date, which is current time. Finally, set content to the updated content. We'll also want a selected node to be identifiable in the sidebar. So in the nodes list, if the node is active node, set the sidebar item active class. We'll also need to add it in the app CSS file. So use the already familiar CSS Modules property called composes to reuse sidebar item style and add slightly darker light gray background color. Now you can see that if we create several nodes and change between them, they have their own separate contents. But the node in the sidebar still isn't changing, so let's generate it from the first line in the node. First, add the title as the second parameter to the onChange function. Move the editor extensions line into a constant, because we will need to reuse it later. Then, in the onUpdate function, assign the editor content to a variable instead of passing it to the onChange function. The content is simply an array of nodes, so we can take the node at index 0, and that's our first line. Use the generateText function from Tiptap to get the text from the node. So when the node content exists, pass it as the first parameter, and as the second parameter, pass the extensions that we moved to the constant before. Go back to the app component and add the title parameter to handle changeNodeContent function. We can assign some default text in case the node has no content. Then inside the setNodes call, update the node title with the one from the parameters. Finally, we need to pass the title from the parameters in onChange function to our handler. Now in the sidebar you can see that the title gets updated based on content. It would be nice though if creating a new node would immediately open it. So in the handle createNewNode function, call setActiveNodeID with the ID of the new node. Now if we click the new node button, it opens up the created node. Good. Now we can move on to saving the nodes in local storage. Create a new file and call it storage.ts. In it, create and export a new object called storage with 3 function properties: set, get, and remove. The set function will have key and value as parameters. The get function will have a key parameter and the default value parameter, in case nothing was previously stored. Its type will be a generic type that we'll call capital T, and the function will return the same generic type. The remove function will only need a key. Now let's write the actual logic. In the set function, we will call local storage.setItem, and because local storage only stores text, we'll convert the value to string using JSON stringify. In the get function, we will use local storage.getItem to get stored text, and we'll parse it using JSON parse function. In case there was no value stored, we'll return the default value. In the remove function, we'll simply call local storage.removeItem. Now we have our abstraction over storage. So let's import it in the app component. First, create a constant for the storage key to use. It can be in a string value, but let's call it nodes. Then create a saveNodes function that accepts a node and parameters. In the save function, we'll need to update node IDs to include the new node if it doesn't exist yet, and then save the actual node data. So inside of the saveNode function, we'll call storage.get to get an array of node IDs. We'll then filter it to remove the ID of the node that we're saving in case it already existed, and we'll add it at the end. This ensures that we don't add the same node ID more than once. Then let's call storage.set to save the actual node data. But as the key, let's use the combination of storage key and node ID to make it unique per node. We'll simply separate the parts with a column. Finally, let's call the saveNode function after we create a new node. You can see that now a new record appears in the local storage when we click the new node button. Now we can create a function to load the nodes from local storage. But before that, I'll move the saveNode function outside with the app component because it doesn't directly use any component state. Let's declare the loadNodes function and get the node IDs from storage. We'll then need to build an object that maps node IDs with the nodes so that we can put it in the component state. Now let's go through all of the node IDs and get individual nodes from local storage. Then we can add them into the nodes list, and since the updated at needs to be a date and in local storage everything is a string, we need to create a new date object from the updated at date string. Let's finally return the nodes record and call the function when we initially set the node state in the app component. And you can see that if we create a new node and refresh the page, the nodes don't get removed anymore. We will be using the same saveNode function to update the node as we type. But it isn't a good idea to save the node on every keystroke. It might not matter much when we use local storage, but if we used actual backend APIs, we would be sending a network request for every character we type. So we will implement a technique to mitigate this called debouncing. So let's create a file called debounce.ts and inside of it a function called debounce. This function will be what is called a higher order function, meaning that it will accept another function and return the same function but with extra behavior on top of it. In our case, every time we call the function, its execution will be delayed by a small amount of time. So if we then debounce our save function, the user will type, but the actual saving to the local storage will be delayed on every keystroke. So only if he stopped typing, we will save it to the local storage. And that's okay because we only care about saving the final node text. I've added parameters for the delay in the original function. Now we need to implement implement the debounce function. Inside of it, create a timer, which will call the original function after the delay. Now, in case we call the function again, we will need to reset the timer. So save the timer ID and clear the timer every time we call the debounced function. This basic implementation will be good enough for our case. Now we need to add actual saving when node content is being changed. We'll reuse the same save node data that we used in the setNodes function and call save node with it. If you test it, you will see that the node content is now saved to local storage when we type. Let's optimize it with our debounce function. First import it, then wrap the save node function definition with the debounce function and set some small number as delay. I'll pass in 200 milliseconds. If you test it now, you'll see that when you type, the results aren't immediately saved to the local storage, but only once you stop typing. This technique would be even more useful if you wanted to prevent your frontend from spamming a backend server. Right now, you can create and edit nodes. But what if multiple people wanted to use the app? They'll need their own users, so let's build a login page. Create files for the component and its styles. Create the component and import the styles. We'll create a div container for the page and a form that will put at the center of the screen. By default, the browser will try to submit the form using a post request and it would refresh the page, and we don't want that. So let's create onSubmit handler for the form, and inside of it, call prevent default on the event. We need some input fields now. First, I'll create a label that will wrap the label text and the input. We do that so that clicking the label would focus the input field. Give the div a class, then create a text input field for the username and give it a class as well. We'll do the exact same thing for the password field, except for the input type, we'll set password. Finally, add a button with type submit. Clicking it will call the onSubmit handler of the form, so we don't need to add any onClick handler. Give it a class as well. Now let's add the styles for the login page. First, declare the page container class, set the height to 100 viewport height, overflow auto, and flexbox with direction row. Additionally, we'll add justify content center and align item center to move the login form to the center. For the login container class, add display flex with direction column. I'll make it either fill the screen if it's small by setting width 100%, or stay in the center on larger screens with max width of 20 rem. Finally, add some space between the form fields using the gap property. Now add styles for the label text. I'll slightly reduce the font size, set a gray color, and add some margin on the bottom. For the text field, let's make it full width of the form. Give the input field a light gray border and box shadow. I'll also make the corners slightly round. Finally, add some padding on the sides, but 0 at the top and bottom, and give it a fixed height. To make the button look good, remove the borders, and give it a background color. I'll make it blue. Then I'll make the corners round and give it a light box shadow. I also want the text to be white. Now set the height to be the same as the input fields and also give it some padding of the sides, but 0 at the top and bottom. I'll also slightly reduce the font size and change the cursor to pointer. Finally, let's make the button's background slightly darker on hover. We now need to add the login page to our app, but that also means that we need to have separate component for the nodes page. Rename the app files to nodes page and update the imports. Now create the app.tsx file and create the new component that returns the login page. If you visit the app, you should already see your new login page. Now we need to add the state for username and password fields, and also the onChange handlers. They will receive the change event so we can set the state values to event target value. However, first set each input's value attribute to the respective value in state and register their event handlers we've just defined. If you check the app, nothing will have changed visually. But now we can use the field values when we submit the form. Before we proceed, install the Crypto.js library and its TypeScript types. We'll use it both to encrypt the user's passwords and also to encrypt the nodes themselves. We'll want to store user data in the app component state to determine which user is logged in. So first define the types for the callback function that's going to be passed to the login page props. The login page will pass it the user data with username and decrypted passphrase. I'll explain what passphrase is in a moment. Then add props to the login page. So the passphrase will be a randomly generated string that we'll use as a key to encrypt nodes. We could use the password, but what would happen if we wanted to change it? We'd have to decrypt all of the nodes and decrypt them all again with the new password. So if we use a generated passphrase and encrypt that instead, when the user wants to change the password, we only need to re-encrypt the passphrase. So now import AES and DNC objects from Crypto.js and our storage utility. Create a constant for the passphrase storage key. In our handle submit function, we'll either log in the user if it exists or create a new user if it's the new username. So basically it's a registration and login through the same form. So first we'll need to check if the passphrase exists. Let's get it from the storage. To set the key as a combination of username and storage key. If the passphrase doesn't exist in local storage, we'll assume it's a new user and we'll generate a new passphrase, essentially creating a new user. We can call the UID function to generate a random string like we did for the node IDs. Then we need to store its encrypted version in local storage. To encrypt the passphrase, call AES encrypt and as arguments pass the passphrase and the user's password. By default, it's an array of bytes, but we can convert it to string. After registering the user, we should log it in. So we'll call set user data and pass in the username and decrypted passphrase. We'll later use it to encrypt and decrypt nodes. After this, we're done with the methods, so call return. Now for logging in with the existing user, we need to check the password first. We can try decrypting our passphrase with the password, and if that fails, the password was incorrect. So call AES decrypt on the encrypted passphrase and convert the result to string. It also requires the encoding, which we can set as enc.utf8. If the passphrase is successfully decrypted, it will not be undefined, so we can lock the user in by calling setUserData with username and passphrase. In case the password was incorrect, we should show an error. So add some local state to store the error message and set it when the passphrase is undefined. I'll also render the error message at the top of the form. Now go to the app component and add local state for user data. It will be an object containing username and decrypted passphrase. If the user data is set, it means we're logged in, so render the notes page. Otherwise, render the login page. If you now enter a username and the password, a new user will be created and you will be redirected to the notes page. If you refresh the page and then try to log in with the same username but a different password, you'll see an error message. But if you enter a different username, another new user will be created. What is left is to encrypt the notes and store them per user. First, let's create a new type for user data because we'll want to use it in the notes page as well. Then, use it to replace the state type in the app component. Also do the same in the login page. In the notes page, add the user data prop and import Crypto.js like we did before in the login page. We'll do the encryption when saving first, so add the user data as a second parameter for the save note function. All of the notes will need to include a username in their key to associate them with the user. So I'll add it to the getNodeIDs call separated with column. Do the same for the set call as well. Now use the AES encrypt function to encrypt the note with the passphrase. You will need to call the JSON stringify function on the note first though. Then convert the encrypted note result to string and save it in local storage. And don't forget to add the username to the storage key as well. Now let's add the encryption to the load notes function. Add the user data parameter like before and extend the storage keys with the username. Now the storage calls will return the encrypted notes as strings, so we'll need to decrypt them. Do that similarly to how we did it for the passphrase. Pass the encrypted note and decrypted passphrase to the AES decrypt function and convert the result to UTF-8 formatted string. Now we need to pass the user data from component props to the load notes and save notes functions. Finally, in the app component, pass the user data to the notes page component as props. If you test the app now, you'll see that when we create new notes, they're assigned to the user in local storage. If we refresh the page and log in again, you should still be able to see and edit the note. So there we have it, a solid base for a real-world application. Feel free to add your own design, some more text editor controls, and if you're feeling adventurous, store users and notes in a database. If you do this, you can add this to your portfolio and it will help you find a job as a junior developer. But for now, like this video, subscribe to my channel, and see you in the next one.